Hi everyone, I'm Jack and this is the first online SOLIDWORKS tutorial video. So today we are going to be making this piston here. There's quite a lot of features on this piston that will learn you quite a lot of the software. The dimensions that I'm going to be using throughout, I've just measured using a set of verniers, so there's nothing that's going to be too exact, but it's going to be useful enough for the video. So let's make a start. I'm assuming that you've already got the software downloaded and installed on your PC, so I'm just going to take it from there really. So if you go into SolidWorks and click File New, you will get three options as to what you want to do. So you'll get the option to create a part, an assembly or a drawing. In this video we're just going to be creating a part, but there are going to be more videos uploaded soon where we're going to show you how to create an assembly and a drawing. So if we just click Part and then click OK, that should open up a new window. So here's your normal sort of typical SolidWorks layout. So on your left hand side you've got your sort of it's your design tree. So this is where your features and sketches will all appear in the order that you create them. So all we've got now is the three planes and the origin. On the top bar is where your sort of toolbars are. So you've got your feature toolbar. We're going to be using quite a lot of these features, and then the sketch toolbar. So we're going to be using quite a lot of these little sort of sketch tools. Don't worry about surfacing just yet. We're mainly in this tutorial going to cover features and the sketch toolbars. One thing that's important is to make sure that you've got your units down in the right hand corner set to millimeters grams second. The dimensions that I'm going to be using are all in millimeters, so make sure that you've got that set prior to starting this tutorial. We're going to create some sort of variables. So if you before we do anything else, if you go to Tools, Equations, that will open up a dialog box that looks like this, where you get to specify some global variables. So I'm just going to go ahead and type in some variables. Don't worry about what they are just yet. I'll get to that when we get as we get through the tutorial. So the first one is piston diameter. That's got a value of 67 millimeters. So you can put some comments as to what the variable is. That'll make your life easier later on. But these are all pretty self-explanatory. So piston diameter, piston height, that's 49 millimeters. Compression ring height, that is 1.5 millimeters. So you can either click Tab or Enter to go to the next variable. Compression ring depth is 3 millimeters. And then you've got the oil control ring height, which is 2 millimeters. And then the depth of the oil control ring is 3 millimeters. So then we've got the ring radius, which is 0.2 millimeters. So I'll just quickly show you what the ring radius is. So if you've got three rings. So you've got a top compression ring, second compression ring, and then your oil control ring. At the back of these ring grooves, you've got a very small radius. You'll not be able to see it on this, but within these grooves at the back of that ring groove, within there, you've got a very small radius. So that's what the ring radius refers to. We've then got the gudgeon pin, gudgeon OD, which is outer diameter, which is 24 millimeters. Then got the gudgeon ID, which is 18 millimeters. And then we've got the circlip width and depth. So the width of that is 2 millimeters. Circlip, I'll show you what these are when we get around to it. Circlip depth is 1.25 millimeters. So if I click OK, you will see now that on the left hand side, this equation has now got a drop down box. So if I want to edit these equations at any point, I can just right click and click Manage Equations. So let's start off by sketching. So if we go Sketch, it will ask us to select a plane. So we're going to put a sketch on the top plane. So if we click the top plane, once it's highlighted orange, it'll bring it normal to the screen. So one thing to mention quickly before I carry on is that it's important to recognise where possible where you can sort of make use of some of the features. So one of the features that is very important for this piston is to recognise that this is sort of symmetrical around the axis that will go through the centre of here. So if you look on the inside, that's pretty symmetrical. The outside, there's nothing too fancy. So we're going to assume that it's a symmetrical part. So we're going to model half of it, and at the very end we're going to mirror it across. So if we sketch a circle, so if you just click the circle, and then if you click the centre of the origin, and then just click and drag, and then click again to place the circle, we've now got a circle. We want a semicircle, so we're going to have to half that circle. So if we click this top point here, and then go right through the circle and click the bottom point, you can see it sort of snapped it to the vertical dimension where this yellow line is. And then if we click we click the bottom point, and then click escape to come out of that, we've now got two semicircles. We need to trim either half to get rid of it. So if we trim the right hand half using the trim tool, so if we click trim entities, trim to closest, and then the right half, I don't know if you can see that, but that is highlighted orange. So if we click that, we've now got a semicircle. So if we're happy with that, we'll close the dialog box. So you can see here that this sketch is still got some blue parts to it, which means it's not fully defined. So in order to fully define that, we need to specify the radius of this arc, or the dimension if it was a full circle. Sorry, the diameter if it was a full circle. So if we click that edge, place the dimension, we can now use the global variables that we created earlier. So if we type equals, and then down arrow to global variables, then a right arrow across. Oops, they're not showing up because my screen's lagging. It should be here. But what I'll do instead is I'll just type piston diameter. There we go. But because this is a radius and not a diameter anymore, we need to divide that by 2. So I'll do that by typing /2 and then click OK. You can see now we've got a value of 33.5 millimeters. So what's also important to notice is that has got the function symbol. So that it's got the function symbol because when I typed in the dimension, I put an equal sign before it. So if I get rid of the equal sign, it'll still work and it'll still get a value of 33.5 millimeters. But if I were to update the variables and change the piston diameter to 70 millimeters, that would stay at 33.5 millimeters and not update to 35 because it's not a function or a variable anymore. So it's important to make sure that you put the equal sign. So I'm going to do it as it equals. Oops, I put it in the wrong box, that's why. Equals piston diameter divided by 2. And then enter. And then tick. So we've got a sketch. We need to now create that sketch. We need to turn that sketch from a 2D to 3D. So we're going to use the features, and we're going to use the extrude boss base feature. So on the left hand side, you've now got some options. So the first one is where that actually starts extruding from. So we're going to extrude it from the sketch plane. I'll show you these later on. Then we've got the direction, so you can do it blind, up to vertex, up to surface, offset from surface, up to body or mid plane. So we're going to do this one blind here. So that's where you just specify a dimension, and it does it from that surface in one direction. If I were to use mid plane, for example, it would do it symmetrical about the plane that you sort of extruding it from, and that can be very useful in some circumstances. But for this one, we're just going to do it blind. And for the value, we're going to put equals again. You can use the global variables, and again, they've not shown up because my screen's faded. So if I type piston height, if I then click OK, you can see that we've got a solid. So the next thing that I need to do is we've got a cutout on the top of the piston. I'll quickly show you that. So on the piston, the top surface has got a section which is slightly below the surface, so we're going to now put that cutout in. So I can either create a sketch. So we want to, with the sketch, you have to either create it on a face or a plane. So we're going to put it, we could either click that face and then click sketch, or I know that that's on the right plane, so I'm going to click the right plane in the tree, and then click sketch. And now this is quite a useful keyboard shortcut. So if you click Control and 8, that will make that surface normal to the screen, which is really helpful. So we can now start sketching. So the first thing I want to do is create the center line. So we're going to do this as we're going to draw the profile and then cut it out as a sort of a revolve. So I need to put the axis in which we want to revolve that cut around. So if I put that axis in and click Escape, I can now start sketching the dimensions. If I go to the line, so I'm going to start it from the middle. Sorry, click the line. I'm going to start it from this middle point. I'm going to come down, click, and I'm going to go across. So these yellow lines are the sort of guidelines as to what the horizontal lines are or the vertical. So I'm going to make this snap to that. And this is quite an important shortcut as well. So if you move away from this point now, and then move back to it, and then move away, it gives you a radius instead of a line. So we want a radius now that will go all the way up to this top surface. So if I click there, and then to close the sketch up, I go back to where I started. It should be filled in. If I click OK on here, and now what we want to do is add some dimensions. So if I dimension the depth of this cut as 0.5 millimeters, I'm going to dimension where this radius meets the top to the outer edge as 7 millimeters. And then, so you can see now that the sketch is still not fully defined, which means that if I click and drag, I can move this radius and change the value of it. So to make it fully defined, I need to add a value of this radius. So I'm going to make that 5 millimeters. So as you can see, you can either use a global variable. So if I had a variable for that radius, I could have typed that in, or you can literally just type the value in. But the most important thing is that this sketch is all black, which means that it's fully defined. So if I now go to Features, if I do a revolved cut, if I click that, then it should automatically know that I want to use this center line as the axis, which it does, yeah. So you here have to click the axis of revolution, which is why we drew that line in. And then the angle which you want to sweep it through, so 360 degrees will be fine, but you could also do it as 180 degrees. So, but we'll just use 360 degrees. Click OK. And then we've got that cut out. So one thing about SolidWorks and any CAD package is that there's always more than one way of achieving the same sort of purpose. So this cutout, we could do it using the extrude cut, or we could have also done it by doing the revolved boss base and then removing the body. So I'll show you the way that I do that. So I'll just delete this feature, which should keep the sketch. So if I click delete the following item, yes. So you can see now I've got the sketch. So if I now do a revolved boss base, again, it'll know that the axis line is the axis of revolution. But here, where it says merge result, so an important thing here is that if I'd had this ticked, it would merge the body that will be created from this feature with the body there, so we'd have two separate bodies. So what I'm going to do is untick that, so we've got two separate bodies, and then click OK. Now I can see here we've got two solid bodies. We've got one which is the main sort of piston billet, and then we've got the other one which is the cut. So I'm now going to insert a feature. So if I go into the search bar at the top and type combine and click this feature. So what this feature allows you to do is click the main body. In our sort of circumstance, it's the piston body, and then the body to combine is this cutout. So I can either add those two bodies together, which does the same as having the merge result, or I can subtract one from the other. So if I click subtract and then click OK, oops, I didn't click the main body. Yeah, if I click OK with subtract selected, again, you've got that cut out. So that's two ways of doing the same thing. But this way, notice that you have to do it in two separate steps, whereas previously we've done it in one step. So the next part that we're going to do is we're going to do these cutouts that you can see at the bottom. So if you look from this direction, you can see that it's sort of in 3 dimensions. It's going sort of in all axes, it's going in and out of plane. But if you look from this view, you can see that we can just draw a 2D sketch that's this profile here and then cut it back and forward, and then it'll get that sort of feature. So I'll show you how to do that now. So if we want to do it on the front plane this time, so if I click the front plane and then click sketch, Control 8 to make it normal, and then if I just start sketching, if I start sketching using the sketch tool, I can click here, draw a line vertically upwards, move away from the point, back to the point, and then away to get a radius. And then using these guidelines, if I click this yellow line, then this line will be tangent to that radius. If I click there, then move away from the point, back to the point, and then away again, get a radius. And then if I click this outer edge when it's highlighted, and then go down to the bottom corner, and then back to the start to close the sketch. So we've got it. So now if I add some dimensions, if I dimension the height of this to the bottom edge, if I do that as 13 millimeters, you can see it's folded itself up a little bit. So if I drag that edge up, there we go. That's better. If I dimension this as 1 millimeter, if I dimension the point to the axis, that bottom point there, as 11 millimeters, that's sort of the point. Yeah, you can see. If I dimension the radius as 1 millimeter, again, these are all just dimensions that I've had to approximate using the tools that I've got with me. If I put a radius here of 15 mil, so you can see that this sketch is not fully defined. So if I click and drag this line, it should move that radius. If I do it as the point, yeah, it's sort of moving where the center point, this point here of that radius is. So I can either specify where I want that point there to be, or I can just put the angle of this line. So if I do a smart dimension, click that line and the bottom surface, it'll do it as an angle. You can see the sketch has already gone black. If I put that angle as 30 degrees, click OK, we've now got a fully defined sketch, which we can now use the features to do a extrude cut using. If I look from the side now, so the direction this time we can use through all, both, or mid plane. So mid plane would be quite helpful for this because it's going forward and backwards from the mid plane, and we can specify that sort of distance. But if we use through or both, then it automatically, no matter how wide the piston is, will always cut up until that edge. So that's what we're going to use for this feature. So if I do through or both and then click OK, and there we are, we've got that. So as you can see from this side, you've got it sort of cutting in 3 dimensions, but if you just recognise that you can do a 2D sketch on one plane and then cut it through, then that'll save you some time. So the next feature that we're going to put in the piston rings, the grooves for the piston rings. So if we can do it on the face this time. So if I click that face and then click sketch, Control 8, and then if I use some corner rectangles, if I use this edge, then it'll make sure that that right hand edge is always touching that edge of the piston. If I just draw some random size rectangles that I'll mention later, all using that right hand edge. In fact, this one I'll not use the edge. I'll do it in the middle to show you how to constrain it. There we go. So if I click the right hand edge of that rectangle and the right hand edge, and the right hand edge of the piston, it'll bring up some relations here. So I want that to be collinear. So if I click collinear, it'll snap it to that edge. So that's what I want. So when I waited for it to highlight it, that automatically added that sort of relation. So what I now need to do is dimension these piston rings using the variables that we created. So this one is going to be equals compression ring height. This one's also going to be compression ring height. the width of these is going to be the depth of the compression ring. So equals CR depth. Okay, and then I'll show you a different way of sort of achieving the same 3mm for this one. So if I click the edges, click to place a dimension, and then if I type equals, but instead of typing compression ring depth, if I just click the other dimension, then this dimension will always be what that dimension is. So if I click OK there, then it also makes it 3mm and a function of 3mm. So if I change that to 4, that will change to whatever that is, so that'll automatically be 4. So that's another sort of little tool that might become handy. I then need to dimension the oil control ring depth and height. So equals OCR depth tick, and then equals OCR height and tick. So now if I click escape to come away from the smart dimension, these are fully defined other than their sort of vertical heights. So I'm going to add some dimensions in from the top surface. So if I dimension that as 3mm, and then so I can either dimension this next one from the top surface or from the other piston ring. So I'm going to do it from the other piston ring because that's the way I measured it, but also because it depends on how, if you want them always to be relative to each other rather than to the top surface. So if I change that distance from 3 to 5, then the distance between the two of these will still be 2mm. Whereas if I change that from 3 to 5, and that was measured from the top, then that gap there, that 2mm, would disappear. So I'm interested that the gap between the piston rings is more important than the gap between the piston ring and the top surface, which is why in this instance I'm defining them from each other. If I do that as 3mm, and click tick. And then the final thing is the radius that I mentioned at the back of the ring groove. So those radiuses are going to be here and here, or look for each one. So if I click the sketch fillet and I click the point, and if I change this value to, because I think this is a SolidWorks bug, it doesn't let you type. It doesn't let you type any of the variables in here. So if I just put 0.1 millimeters, oops, and then click the other parts where I want the fillets to be, and then click OK, you'll see that you'll get one sort of dimension for all of the radius, because they've got this equals where it sets them equal to each other. So if I now double click this, I can type equals ring radius. It'll let me put the variable there. So now that's changed to 0.2 millimeters. So the final thing I need to do is put an axis to revolve this round. So if I do a center line, do it from this origin, because it's in the center, and to the top, and click escape to come out of that. And if I go to features now, this time I'll do it as a revolve cut. So if I do revolve cut, again, it's automatically known that I want to use that line for the cut. So if I click OK now, we've got piston ring groove, sorry. So the next feature that we want to do is we want to make the inside of this hollow. So I'm going to do that by using the shell feature. So with the shell feature, you have to click the faces that you want to remove. So I want to get rid of this face, and all of the bottom faces. But if I miss a face, it should give me an error. If I put the sort of thickness as 3 millimeters, it should, yeah, we've got an error. So what I need to do is make sure that I've selected all the right faces, and then click OK. And there we go, we've sort of shelled out our piston. But one thing which I learned just modelling this piston is that the thickness of the top face, which will be where the sort of the combustion happens, is thicker than the sidewalls. So one way which we can make that thicker, which I learned just doing this sort of modelling, was to use a feature called the move face. So if I, in the search bar, type move, you can see there's a move face tool. So if I click that, I then have to specify which faces I want to move. So if I click this face and this face, oops, sorry, that's not doing it. Just come out of that second. Sorry, one thing I've noticed a mistake is if I change this compression ring depth to what I actually needed it to be, which is 4mm, and you should see that these will automatically get bigger. There we go. So now if I use the move face and I click this face here and this face, and then I want it to be in the Y direction because I want to move it in this direction by 5mm. You can see there that we've now made that top face thicker. So if I click OK, there we've got it. So that's now a thicker face on the top than it is on the sides. So there's probably a lot of ways of doing that, but I just learned. I was wondering how. I was just exploring the features and came across the move face feature. So that's one way that you can use it. So we're now going to fillet sort of between this face and this face. So we've got a nice. So the sides not got a lot of sharp corners here. So if I go on the fillet tool, oops, not linear pattern. If I go on fillet, and then face fillet. So for the face fillet, you have to select the two faces that you want to fillet between. So the first face is going to be this one, and the second one is going to be this one. So if I change the value there now to either 5 or 6mm, I'll use 6. You can see now that you've got a much better sort of surface on the inside. So I'm much happier with that now. The next feature that we're going to do is we're going to sort of create the material where the gudgeon pin comes through. So we're going to create a sketch on the right plane. So if I click right plane, click sketch, Control 8 to bring it normal to surface, and then I'm going to draw 2 circles. If I draw one here, and then for the second one, if I start it at the center point of this one, then it'll make sure that those circles are always sort of concentric to one another. So if I click tick, and I then add some dimensions. So this one is going to be the gudgeon outer diameter, and then this one is going to be the gudgeon inner diameter. So I now need to sort of make sure that this is fully constrained. So if I can still move this anywhere. So if I select the center point of that and then the center point of the origin, the relations will come up again. So if I make that vertical, then that makes sure that the only way that this can now move is up or down. It can't move left or right. It can only move up or down. So if I specify the distance that I want that, if I put that as 25mm, there we've got it. So I can now, if I exit the sketch, you could, if you were to use the extrude boss base feature and then change the direction so it goes through it, you can see that we're going to get some unwanted material here, which is not what we want. So unfortunately for this, we're going to have to do this in 2 steps. We're going to have to do the outer diameter and then cut the through hole. So where it says selected contours, if I get rid of this and then just select the outer diameter, what I can use now for the direction, I'm going to use up to body. So as you can see, before it went all the way through it, if I just click up to body and then click this surface, you can see that where we've got this sort of radius here, it only follows it around the inside. So that means that we don't get this unwanted material here. So that's what we're going to use. So if I click up to body, and then the other important thing, if I just show you on the screen, is that it doesn't start in the center, it's actually got an offset. So we can use the offset feature here as well. So if I do it from and then offset, I can put a value in here. So if you can either scroll or type it. So if I put 17mm, which is how I measured it, you can see it's in the wrong direction. So if I flip that It then starts 17 millimeters from the middle axis and then only goes up to the body. So if I click OK, there we've got it. So that's good. So then what we want to do is we want to add a draft angle to that. So if I click draft, the neutral plane is sort of where it gets sort of pulled from. So if I click the bottom face for that, I could either use the face or I could use the top plane. They both give me the same result. So if I delete that, I can use the top plane. And then the face to draft, we want to draft this face by an angle of 5 degrees. So I'm happy with that. So if I click OK, you can see that's now got a draft angle. But it's in the wrong way, so we need to flip that. So we need to select, instead of selecting the bottom face, if we click the neutral plane, if we set that as the top face, you can see this arrow. If we click that and flip it, there we go. And it's now doing it in the right direction. So the next step that we're going to do is we are going to add some fillets to this edge here. So we've got a sharp edge here and a sharp edge here that runs all the way around. So the order of the fillets is very important. So if I click the fillet tool, and then instead of using a face-to-face fillet this time, if I do a constant size fillet, if I change the value of that to 2 millimeters, if I click this edge here, you can see, and this edge here, you can see that it will, for the next fillet, it will create a smooth line that goes all the way up. Whereas if I clear selection, if I wanted to add a fillet just to this edge, then it wouldn't wrap it all the way around properly. I'd have to do it in 2 steps. If I clear that and then click this edge and this edge, and then 2 millimeters symmetric, click OK. When I do the next fillet now, and if I click this edge, put a value of 1 millimeter, then the fillet will go all the way around it in one simple, like one motion, which is what we want. So if I click OK, we've now got no sort of sharp edges on the inside. I can also add a fillet to the sort of gudgeon boss. I can add a fillet of 2 millimeters. So the next thing we need to do is we need to cut the hole where the gudgeon pin will actually go through. So if we go into the boss extrude that used that feature, if I show that sketch, you can see that sketch is now there. So if I click extrude cut in the feature, I can either click a plane that I'm going to use it from or click an existing sketch. So if I click that line, you can see that we want to use the through all feature. I can either do it blind or through all both, but through all will be fine for this example. I'll go right to the very outer edge. So if I click OK, click the tick, we've now got sort of the hole going through without the extra material here in this piston ring groove, so that's what we're happy with. I can then add a chamfer. So instead of a fillet, if I do a chamfer to this outer edge, so if I click here, and if I specify the sort of distance as 1 millimeter and the angle as 45, click OK, we've got a chamfer there. So that's happy with that. So if I just go back and hide this sketch, then you can see that this piston's sort of very much nearly finished. The last thing that we've got to do is the groove for the circlet, which sits in here. So there's more than one way of doing this, but the way I'm going to use is to create a point, then create a plane, and then cut it that way. So I'll show you. So if I go reference geometry, create a point, I want that point to be on an arc center. So if I click arc center and then click the arc that I want it to be on the center of, you can see there now that the point has gone perfectly in the middle of that. If I click OK, if I then go on to reference geometry and click plane, the first reference is going to be that point. The second reference, if I make it parallel to this top face, for example, because I know that's flat, then we've got a plane now that is sort of on that point and parallel to the top face, which is great. So if I click OK, excuse me, I can now, using this plane, create a sketch. So if I click Control 8, And so now I wouldn't be able to see where I'm sketching because there's material in front of, between me and the plane. So if I click section view, then there we are, that's what we want. So if I now start, if I click OK on that, if I start sketching, so I'm wanting some sort of rectangle. So if I just draw a rectangle and then add some dimensions, this is going to be the circlip width. So equals, using the variables again, are they going to work? No. Circlip width, click OK. And the next one is going to be the circlip depth. Right. So I now need to specify the distance of this to the origin. So if I put a distance of 25 millimeters, and you can see we're still not fully defined. So I can click and drag this, and it'll move it. You can see it'll translate it vertically. So I need to specify the distance between this edge and the origin. If I place that, see, I can be smart here and use the global variables that I created earlier. So if I type equals gudgeon ID, but because this is a radius and not a diameter, if I divide that by 2, you can see that it'll snap it to that edge. So if I change the ID of the gudgeon bin, then it'll automatically change the sort of ID of this cutout. So that's really good. And then the last thing we need to do is we need to create a center line in which we're going to revolve this cut around. So if I draw it from the origin to the point, and make sure that that's, you can see the sort of relations that that's got a horizontal relation already. Then escape. Got an all black sketch, which is great. And then if I go to features and then do a revolve cut, it'll spin it around 360. If I didn't want this to be a full cut, I can just change that value. You can see it's not cutting it all, but I do want this to be a full circle. So I'll make that 360. Then click OK. Now we've got it. So if I come out of the section view now, we've got pretty much half, well, we've got half a piston. If I just hide the plane and the point by clicking them and then clicking hide, good practice, we've got as piston. So the last step we need to do is to mirror it. So if I go to mirror, you can either mirror a feature, a face, or a body. I'm going to use a body this time. So if I click the body that I want to mirror, and then the plane in which you're going to mirror it about, I can either click this face here, or if I clear that selection, I can do it around the plane that I drew that on. So I can do it around the right plane. So there you go. If I click there. So there we have it. Got a piston. A lot of features there. So we've got extrude boss, we've got revolve boss, we've got cuts, revolve cuts, we've got fillets, drafts, shells, move face, mirror. So an important thing to notice is on this left hand side, if I want to scroll back to any point, I can take that line and scroll it back. So that's when I did the fillet. So if I now were to do any features, those features would happen directly after this fillet. So that's quite an important tool. So if I scroll back down to the cut, and that's before the mirror. So if I wanted to add any features before I mirrored it, then I'd do it in here. So for example, if I wanted to add a fillet to the top surface, for example, if I click that top surface and I do it as just a constant size fillet and put a dimension of 1 millimeter, if I do that now, you can see it's before the mirror. So when I mirror it, it mirrors the whole body with that fillet on. So that's really helpful. So there's your piston. So we've done, like I said, we've covered quite a lot there. You will get used to things like just rotating the mirror, the window, the part around in the window. So that to do that, you click the mouse wheel. So this is one thing I'd recommend is having a proper mouse and not using your trackpad on your laptop. And then if you want to move it, if I click Control and click the middle mouse wheel, I can move it around that way. If I zoom into the wrong part, I can click this button here, which zooms to fit. That's a helpful tool. But so the main thing is sort of just practicing. You will only get better at SolidWorks by practicing. There's a lot of tutorials built into SolidWorks. If you go and help, there are some SolidWorks tutorials here which I'd recommend doing. The global variables are really helpful. If I wanted to change the piston diameter now, then it would update it all the way through. If I wanted to do the gudgeon, I'll change the gudgeon pin ID, for example. So if I change that from 18 to 10, and click OK, when it takes its time, you can see now that the gudgeon ID has changed to 10, and because I set, when we did the circlip cutout, I used that variable as well. That cutout was kept with that sort of the idea of that gudgeon pin. So I'll change that back to 18. So hopefully you've learned quite a lot of tips. A good one that I use is the Control-8 function. I use that very often. But the sort of number one rule is to make sure that all your sketches are fully defined, and you can tell they're fully defined because they'll be black. So there we have it. There's your piston. Like I said, the dimensions are only an approximate; they're not exact. If you've got any sort of questions, or if there were any bits that you got stuck with, then you can just drop me a message. So I'll just show you one more thing. If you can never find any function, you can either search for them up here, or you can either go on Insert, and then they'll be here. So you've got your surface functions, face functions. That's where the move face one is. You've got all your features in here. So that's another place where you might find everything. So I hope that was helpful. Like I said, if you've got any questions, just drop me a message. So yeah, thank you.